Today we will solve a linked list based problem, and here the task is to group together all the even and odd nodes. And by odd nodes we mean the position of the node, not the value in the node. It may be possible that all values are odd. Then we will call that this first node, third node, fifth node, these are odd nodes, and second, fourth, sixth and so on, these nodes are even nodes, irrespective of what value they are holding, whether they are holding odd or even. And the task here is to do it in order n time, that is linear time. And you don't have to use any extra space. So time complexity should be order n, where n is the number of nodes in the linked list, and space complexity should be order 1. So let's see. It's not a tough problem. If you can reverse a linked list, then you will most likely solve this question as well. So let's understand it first. So this is the original linked list, and after grouping them, this 1, 3 and 5 comes first, followed by all the even nodes. And don't be confused about this values. These can be anything, odd or even. Their position matters. So this is first position, third position. In this case, position and value are same. So how should we approach this? So let's see. You see that this is the next pointer of this first node. So just a quick reminder, recap of linked list node. So a node has a value, in this case integer value, and a next pointer. And this next pointer is itself a pointer to another node, and this is int. So these are the two values that are denoted by one linked list node. So here we will store the value, and then the second section will be next, which will store the address of next node in the list. So this arrow denotes the next pointer. So what we have to do, we have to make this next point here, and this next can hold only one value. So if we make its next point to this node, then this connection will be gone. Similarly, we have to make this next point to this, and again this next point to this, and this next point to this. So this is the thing we have to do for till we reach the end. So it looks very intuitive what you have to do here. If you do this, then your task is done. You will just need to do one more thing. So here, after, let's say we have made these changes. So how we can do it? We will keep one odd node pointer and one even node pointer, initially pointing to first and second nodes. So what we can do, we can make odd next, that is make this arrow, where should I point this arrow? Even next. So whatever is the next of even, and what is the next of even? Next of even is currently 3. We have not yet changed these arrows. We are looking into the original list. So next of even is 3. So make odd next. Odd is 1. So 1's next will now become 3. So it will be 1, 3. And we have not changed any other pointer after this statement. So this arrow is introduced and this arrow is gone. Now also we will change our odd pointer, odd equal to odd next. So odd next is 3. This was the odd initially, and its next we have made it 3. Now we move odd here. So now odd is here, and this connection is done. Even is here. So what we can do, we will make the same logic, because we are repeating the logic. Its next we are making evens next. Whatever was evens next, we are making this next. And similarly, evens next, we are making whatever is the next odds next. So we have already moved odd one step ahead. So you will think that before applying this logic, when we are applying this logic to odd, its next element is the current even. And when we will apply this same logic to even, we have already moved next odd as its next node. So odd is this one. Currently we have shifted here. So its next is 4. So now even next is 4. So this arrow is introduced and this arrow is gone, since this arrow can just store one address. So this will be gone implicitly. And now our task is to move even here. So what we will do, even equal to even next. So now you understand the logic. After this one step, we will take this in pair and consider it as one step. Once next has become 3, odd is here, and other pointers we have not changed. For 3's next will still be 4, and 4's next is 5, and then null. And what we have done here, 2 is there, 2's next is 4, and 4's next is 5 and 6, and even is here. So even is here, odd is here. So this is the state of this linked list after one step. So we have taken one step. So we have, you can see two lists diverging, two lists converging into one. So what we can do next, make, even is pointing here, odd is pointing here. So if we next point it here and this arrow here, then we will be done. So finally we will be left with 1, 3, 5 null and 2, 4 null. So we will have these two linked lists now completely separated from each other. Then our task will be that whatever is the current odd, make its next point to this. So then we will get this one, 1, 3, 5, 2, 4. So for that we will keep two additional variables. We will keep this as head, or we will call it odd head, and the next we will call it even head. Head even. We can initialize it in the beginning itself. And these will not change. These odd and even are the pointers which we will be changing. And in every step we are doing just this thing, these 4 things. So make this arrow point here, make this arrow point here, and move this pointer to the next odd, and move this current even to the next even. So we are done till this step, and we will repeat the same thing. This will keep repeating till we reach end, and one of these become null, or strictly even becomes null. So let's run through this example. So there are 2 cases. Let's run through both. This is the odd case. We have odd number of elements. So after first step, h odd is here, h even is here. So we make this point here, and now odd is here, and we make this point here, and even is here. In next step, what we will do, we will make this point here, and odd comes here, and we will make this arrow point here, and even comes here. Now let's see, even has become null. So we have 1, its next is 3, so let's draw 3, its next is 5, so let's draw 5, its next is null, we have not changed it. And head odd will be here, we are not changing head odd and head even. Now there is no other connection in this list. Now what is the other one? No nodes next is h even, we had detached it, so it's independent. 2 is here, and this is h even. 2's next is 4, 4's next is null. So this is the state, and odd is here, because after changing it we move odd next. So what we have to do, we have to do odd next equal to h even, and h even is in the beginning, always pointing to the second element. So this next will point here and not null now. So the final result will be 1, 3, 5, 2, 4 null, and h odd is pointing here. So this is the new linked list and the desired linked list. You see that odd nodes have come together followed by even nodes, and we have to return the new head of the new list. So we will return h odd. So this was the odd case where even has become null. So next look at the even case. These are the only two possibilities. Either it will have h odd number of nodes or even number of nodes. So h odd is here, h even is here, odd is here, even is here. So we make this point here, and now odd comes here, and we make this point here, and even comes here, and again we make this point to here, but we will not do this. When we see that its evens next is null, then we will not do this. So we will stop here. So once we stop here, what will be it? 1, its next is 3, its next is 4, and its next is null. And where is even? Even is here. So we can write 2, 4, or better, it's converging here. So this is even. Even is pointing here. Odd is still pointing here, since we did not change this next, because then odd would become null, and we were doing odd next is h even. This we have to do, and if odd is null, then we will not be able to access its next. So these are the two scenarios. If we have odd number of nodes, then even will become null in this loop, so we don't need to worry about that. But if we have even number of nodes, we will see that in this last step we will not do this. So we will stop here itself, and whatever is the even nodes, it will both converge to the last node. So what we have to do, we have to do odd next should be 2, 1 3 2 4. Its result should be 1 3 2 4 null. So we will do odd next equal to, this is h even, this is h odd, h even. So we have changed it here and return. So let's write the code for this. You can run through this example again, and it should be very clear. I think it's much more easier than reversing a linked list. So let's write it in C++ first, then we will do it for Java and Python. So if head is null, or head is there but its next is null, that is there is just one element, one node, then we don't need to do anything. Then simply return head, nothing required. Else we will create a few pointers, h odd, h even, and both will be valid because h is valid and its next is valid, we have already checked. And odd equal to h odd, even equal to h even. Now while even, if even next, then odd next equal to even next. So this way we are making sure that odd never becomes null, so that in the end we can assign odd next equal to the head of even. Else If events next is null, then we will do this case. Events next is null here. So we don't change this pointer, but directly make its next point to h even. So exactly that thing we are writing here. And we are done. So we will return h odd. So this check is required for, again, reiterating this even number of nodes. Even comes here, its next is null. So what we do, we make its next point to 2. That is the head of even. So it will be 1, 3. So if events next is null, that means there are no more odd nodes after that. So we are done with odd nodes. So we are ready to make the odds next point to the first even, which is 2, and we will be done. And otherwise, odd equal to, if we did not enter this case, then odd equal to odd next, even next equal to odd next, and even equal to even next, and we are done. Finally, we need to return the head of this odd, h odd. So when even becomes null, we will in the end make this step and also return h odd. So this will happen when we have odd number of nodes. Why? Let's see. This is the case. So here odd comes here at 5, the last odd node. So odd will in the end always be pointing to the last odd node after this loop ends. And even will become null in this case. So this is this case. Even will become null, but we have still not changed the odd next to h even in this case. So we will do it in the end. After this step, 5's next will become 2, whatever was the first even node. And in the even case, we stop here prematurely, and when events next is null, so either even will become null or events next will become null, one of these. This will become null in the case of odd number of nodes. This will become null in the case of even number of nodes. So in this case, we will make odd next point to this, and in this case, we will do this after the loop ends. So let's run it. So it works for this case. Let's add this one. So just add the case of even number of nodes, then 1, 2, then 1, and also empty. Let's try all these cases. And it works for all of these. The expected answer is same as this one. So let's submit. And the solution is accepted in C++. Now we will quickly copy it and do the same thing for Java and Python. And let's try. Line number 20. And this works as expected. So let's go ahead and submit. So the solution is accepted in Java as well. Now we will write the same thing in Python. Python 3. And this works as expected. So let's submit. And the solution is accepted in Python as well.